means push X means that we have to push an item from this location of memory to the top of the stack. And pop X means we have to pop or delete the top of the stack element and keep it in the location X. Okay, and these two are one address instruction. Okay, and zero address instruction means only the opcode will be there, no address will be mentioned in the instruction. For example, add. If I say simply add, that means you are familiar with evaluation procedure in the stack organization. So whenever add instruction or any zero address instruction will be met, then the topmost two elements will be popped and the operation like add, subtract, multiplication, division will be performed in between them, and the result will be pushed into the top of the stack. Right? Okay. Now all these types of CPU organization have to be explained by taking an example. Okay, arithmetic statement, and let's solve it. See, we have to evaluate this expression. It is arbitrary. Okay, you can take another example also. For the time being, we have to evaluate this expression using 3 address instruction. Okay, here we'll be writing instruction and the register transfer language will be written here. So firstly, A plus B has to be added. Next step will be to add C and D, and the third step will be to multiply the result of these two additions. Right? Okay, now we are about to use 3 address instruction. That means in an instruction 3 addresses will be present. So I can write this add. My first task is to add A and B, right? So I can write add. The result will be stored in R1 register, suppose, and the sources are A and B. I can write it because it is a 3 address instruction, and its RTL will be R1 contains what? Aim of A, memory word A, plus aim of B. I can write it. Next step is to add C and D. Likewise, I can write add R2, C, D. That means in R2 I am storing addition of aim of C plus aim of D. Okay. Next step is to multiply them, and I have to keep this result of this operation into X location. So MUL multiplication, destination is what? X this time, and we are multiplying whom? R1 and R2. That means aim of X contains what? R1 multiplied by R2. Clear? Let's begin 2 address instruction. See, in 3 address instruction, we have to explicitly mention the address where we will store the result. Right? In 2 address instruction also, it is not implied accumulator. It is a difference between 3 address, 2 address and 1 address instruction. Okay, here no implied accumulator is there. In 2 address instruction, I can mention only 2 address in an instruction, right? So my first step should be to move A into a register. Then I can write add instruction R1, B. Right? R1 contains aim of A, and R1 contains now content of R1 plus memory word B. Okay, I know your question is, why can't we write this add A comma B? It is a to address instruction, but why can't we write this? Actually, for addition or any kind of operation, we need a register. You are familiar with 8085 instructions, like only add B or add C, like this, because here accumulator is implied. The content of accumulator is added with the content of register B, right? But here A, B, C, D, whatever is written here, we are considering these as memory location, not as register. Okay, that is why without any register we cannot perform any kind of operation. That's why we cannot write this add A, B. We cannot write. Okay, got it? Fine. So our next step should be to move C into R2 register. Okay, and then add the content of R2 with MD. Next step is to multiply them, right? Multiplication between whom? R1 contains A plus B, R2 contains C plus D. So multiply them. If I would have written MUL R2 comma R1, then I had to write R2 contains R1 and R1 multiplied by R2. Okay, this is source and this is destination. Remember it. Now we are yet to move the result this to location X. That is why I have written move X comma R1. That means R1 is the source which contains A plus B into C plus D, and I'm moving this content to X location. That is why this is RTL. Clear? Okay, now one address instruction. In two address instruction, we have just seen move R1 comma A, R2 comma B, whatever, right? So since it is a generalized format and it is not actually 8085, okay, so you need to know that in move instruction two address fields are there. Okay, remember it. Now in one address instruction I am going to use load, store, but you are familiar with LDA, this LDA, STA. You are familiar with this, with these instructions, right? LDA means from main memory to accumulator, right? STA means from accumulator to main memory, right? But here we cannot use this LDA. We have to write LOAD, load, not LDA, because it is specialized form in 8085, but it is a general format because we are studying the types of CPU organization, right? Here may be 8085, 8086, 8088, whatever. Okay, so STA means store. We have to write store, not STA. Remember it. Okay, okay, let's start. In one address instruction, you need to remember two things. This is implied accumulator, and one address instruction you know already, so it is implied accumulator. Here if I write add B, that means the content of accumulator and the content of M of B are added and the result is stored in accumulator. Okay,